Hello and welcome to the programming lecture for this week. This one's going to be about asking questions. So, when is something something else? Here are my goals for you, and let's get started with variables. So if we go to Scratch, start creating scratch.mit.edu, it loads eventually. You can do it, Scratch. Wow, this is horrible. It's way too slow. Okay, now it's working. Let's make it giant like last time. Now on all these sides, we've looked at quite a few of these already, but there are some more that we're going to care about now. We'll definitely need this in a second. We'll definitely need this in a little bit. And one of the things that we will talk about today and we will need is this variables section. So you can make a new variable, take this one, maybe give it a new name. Yeah, you can rename it with a right click, or you can delete it. But let me zoom into that too. Okay, so here's our Scratch cat. Sprite1 is his name this time. And let's talk about variables just quickly. So a variable is, you can think of it as a box. Okay, so it's a place where you can put stuff. So I can make a box called X, and I can put whatever I want inside of it so that I can use it later. So instead of saying, like, I don't know, 1,234, I can put that into X and just say, I don't know, X plus 1 later, ... after some amount of time, instead of having to say, I don't know, 1,235. And this gets extra complicated with large numbers. You don't have to type as much. Or when you want X to be what the user entered. Okay, so you can get like input from the user that you don't know ahead of time what it's going to be. You can ask the user for it, and after they enter it, you can do stuff with it. You can say like, okay, 42 plus 1, X plus 1. And you wouldn't have known ahead of time that the user was going to enter 42 because they could have just as easily entered 43. But then you can always just say X plus 1 and get what you wanted out of that, and that will print 43. Okay? So that is kind of the idea of variables, and let's use our first example of that. So we want to make a program that says hello and then the user's name. So we're going to ask for that. Okay, so let's ask for the user's name. Dun dun dun. So if we go on up, there's this ask block in sensing. Okay, so we can ask something. And it's already set to, how nice, what's your name? Okay, so we're going to have this sprite, because that's the one that's clicked right now. The sprite itself, because this program is currently acting only on the sprite. Every individual sprite gets its own little program window. It's going to ask, what's your name? And then it will wait. Okay? And then let's try running this now. Go. What's your name? My name is Lawton. Thanks for asking. And you can probably hit enter, but you can also probably click this little checkbox. And now it did nothing. What? Well, to access what just got entered, you can use this answer variable. Okay? So it's a special one. It's pre-made for you. It is the other half of this ask block. So I can click it. And it's right now set to Lawton. Okay? Notice that it's not a block itself. You have to use it inside of a block. Okay. Which is fun. Now, okay, so what have we done? Ask what's your name and wait. So what we did when we ran this program, I clicked the green little sign, the flag, and it went and asked, what is your name? And then it stored inside of the answer variable. It made a little box for itself. It always existed. Maybe there was nothing in it originally, but now it holds Lawton. And if I were to rerun the program after some amount of time, I can ask a second time perhaps, or I can run it again. Maybe my name is now, I don't know, Sarah. And now, if I click answer, it says Sarah. Sorry if your name is Sarah and you're in this class. I'm not picking on you. It's a good high school friend of mine. His name's Sarah. Okay. Now, all right. Now that we know what's getting put in this answer variable, how do we use it? Well, one thing that we can do is say, hi, your name. So we know how to say things already, right? We can say hello for a certain amount of time, or just say it. I like the amount of time. Say hello for 2 seconds. But we don't want just hello anymore. We kind of want this variable in it. You can immediately just put answer there, and it'll just repeat your name to you. So in order, it's going to do this. It's going to ask, okay, what's your name? Then wait for you to type it in, and then after that's been done, it'll then move on to this block, and then it will say whatever that name was for 2 seconds. Okay, that's the idea. So, what's your name? My name is Lawton, thank you for asking. And then it says Lawton for 2 seconds, and it should go away. Okay, well, that's nice. It remembers my name, it's saying it back to me, but how do I make it say hello, Lawton? Okay. We're going to scroll all the way down, and you can click these operators, okay? These operators down here, you can look at the other ones, and they have like some examples inside of them already. But these blocks, these 4 right here, starting with join, then contains, these work on what are known as strings. So a string is a bunch of characters. It's like a word. String as a brand new word for us. A bunch of characters. And that's in contrast with things like numbers. For example, not a number. Okay? So we call those strings in computer science for some weird weird reason. You can think of like each individual character like a little letter on a friendship bracelet or something like that, and you're stringing those together to make a word or a sentence. Things like that. That's the idea. So, okay. Let's use them. So join apple banana. If I click that, it says the answer, what it becomes. It will take the first thing and put the second thing after it and make one big string, okay? And it's actually apple space banana, if you can see that. If I just said apple without a space banana, it would put them together in the same word. We don't like that. So we're going to say hello, comma, answer. You see that? And so right now, answer is set to Lawton, because that's the last time I ran the program. And it'll say hello, comma, Lawton, without any spaces, because I forgot to put a space right there. So it says hello, comma, Lawton. Okay, put it there. What's your name? Lawton. Hello, Lawton. For 2 seconds, it'll say that. Thank you, Scratch Cat, for welcoming me. Now, we're not done. I wanted that exclamation point. How am I getting that? Well, think about it for a second. Think really hard, and the answer is another join. We can put joins inside of joins, okay? So this is what I'll do. Join first, the little join, hello, comma, Lawton. So that'll make, this is kind of complicated, so let me do this. This is the answer, and let me show you why this works. Let me just make a blank page now. So the reason this works is because answer currently holds Lawton, remember that. Lawton is sitting inside of the box. That is the variable answer. And it's a string. It's not like a number. It's got like quotes around it you can think of. So that's what answer is right now. And when I say join, the first join, the inner join, which is a horrible pun if you ever get into databases. So the first join does this. It takes hello and puts it with a space. There's a space there. There we go. Hello, comma, space, Lawton. And that's what I get out of the first join, okay? And then this outer one takes whatever the first one gave it, which is this whole thing, hello, comma, Lawton, and puts an exclamation point at the end of that. So this takes this, sees it as one big thing, that is this whole join block, and then puts it together. Hello, comma, space, Lawton, exclamation point. Okay, that is the idea, and isn't that nice? Now you can just put as many joins as you want. Dun dun dun. So that says hello, comma, Lawton, exclamation point. We'll put that in there in a second. Can I copy you? Duplicate. Oh no, Control Z. Duplicate. Over here, please. Alternatively, join is what's known as an associative operator, which you do not ever have to know what that means, but all I'm saying is you could have done this equivalently. First you join hello space with another big thing, which is the answer, and then an exclamation point. Put that right there. These are equivalent. Hello, comma, Lawton, exclamation point. Hello, comma, Lawton, exclamation point. Okay? In essence, they're doing different things first. This join has to be finished. It has to find the answer for it before it makes hello go in the front of it. Whereas this join, before it does anything, oh no, it has to first figure out, well, what is hello plus answer together. Okay, so they're kind of doing the same thing, but at the same time they're not. Okay, no more of that. So I'll put this one in here, and am I just in duplicate mode right now for some reason? Alright, I'd like to delete that. I'd like to delete that. And so now, when we run this program, we'll say, what's your name? It's Lawton. Hit enter. Hello, Lawton, for 2 seconds with an exclamation point. Isn't that beautiful? How are we doing? Alright, so that's variables. Let's use something other than strings. Let's use numbers. Okay, so let's get the absolute value of user input. Okay, let's do this. So instead, actually, let's talk about some extra events. This will be important later. So perhaps when I click the sprite, it'll do something different. It'll start a new program. It'll instead ask, boop, boop. Say nothing right now. It'll instead ask, enter a number. If only I could spell please. And then we're going to say back the absolute value of that number, and I think you know the drill now. So after this happens, after this ask block executes and runs, it will then store in the special answer variable. Where did that go? There we go. In the special answer variable, it will store what number we entered. Okay? So, assuming this works out, what's going to happen is answer will not be filled with a string anymore. It will be filled with a number, like 42. All right? So let's just prove that that's what's happening. Dun dun dun. Boop. So when this sprite is clicked now, it will start the program. Isn't that interesting? So I'll stop that. So I'm going to click this sprite, and now it's going to start this program as opposed to this one. It has a different event. So enter a number, please. 42. So now answer holds. If I click on it, it'll show me what's inside. 42. All right? So we don't want to just say 42 because we want to get the absolute value of these numbers. So I want to be able to say 42 and it give me back 42, but I also want it to be able to do this. If I say negative 42, it gives me back positive 42 because that's what an absolute value is. Yeah? And this will be useful one day in your future, I'm sure, when you're programming. You don't want to go off the screen, so you want to make sure that your coordinates are never negative, for example. But actually, in this world, we can have negative things, unfortunately. But that's okay. So, enter a number, please. Answer. We don't want to say just answer. We can go down to operators again, and now we have a bunch of different options. We can say, I don't know, answer plus 1. That's our negative 41 in this case. You can do the same with minus. The star means times. Slash means divide. Random numbers will be fun. Those we'll get to. Those we'll get to. Joins don't really work as you'd think. It would convert it to a string. It's no longer a number at that point, I don't think. And so now it's like blah with answer at the same time. So negative 42 blah, if that makes any sense to you at all. But no, we'd like to use answer as a number, please. So here is one we can use. We can say abs. Abs stands for absolute value. Okay, you can have other options here too that we might get into. ln for natural log, log for log base 10, I assume, e to the something, 10 to the something, and all your favorite trigonometric functions. So we can say abs answer. Okay? Clicking that, it will now make positive 42 because answer itself, remember, was negative 42. Isn't that cool? So then we can say the join this. The absolute value of, now we're going to use multiple joins here, so watch out. The absolute value of answer, we want to duplicate answer, of answer, this will take a few joins, don't worry, we'll get there in time. Absolute value of answer, then we want to say is space, actually some spaces around is, let me just get rid of all the spaces just to show you what's going to happen. And then we'll say abs answer. Do you see where we're going with this? Go there, please. So this is a very large join, but it's what we want. We want to say the absolute value of, then the answer is, maybe a colon, then answer. And if you want to use an extra join, you could put a period. But every time you want to add separate things, you have to use a new join block, if you can see that. Now you have many options to where to put the join, but it'll all still work out if it's in order in the end. Okay, so let's watch this work. Stop. Enter a number, please. 42. The absolute value of 42 is 42. Let's have this say it for a bit longer. We gotta read. We need time. Oops. 42. Look at all the lack of spaces right now. So we need some spaces after the of. And then it'll print the number, but then we need some spaces after the number but before the is, after the number before the absolute value. Then it'll probably look right. 42. So the value of 42 is 42. Yes, it is. Okay. Stop. Click it again. Negative 42. And this can work for decimal numbers as well. Negative 42.5. Enter. The absolute value of negative 42.5 is 42.5. Isn't that beautiful? Okay. I know this isn't as pretty. Maybe we can give him like a random backdrop again. But there we go. To make it slightly prettier. But this is down and dirty. We're programming. We're doing hardcore things right now. Okay. So, isn't that fun? One thing that I do want to say, so that I get you interested in things, and then I also want to talk about custom variables. Boop, boop, boop. One issue, you can think of it as an issue, is that our programs are currently straight lines. So, what this means is that our blocks, you can think of them like this. Like, our program starts, then we have a block, then we have a second block, and then perhaps a third block. On and on and on until our program's done. And this first one's the event that starts the whole thing. Maybe it's our flag. the idea is our programs are sequential. They are in order right now. So first A happens, then B happens, then C happens, given the event starting the whole process. So our programs look like straight lines. First goes A. Let me use circles instead of boxes because that might get confusing. First happens A, then happens B, then happens C, and if that's the last thing, our program's done. We would like, let's daydream with the rainbow, we would like something like this. Not all programs can be arranged like this, so it would be nice if we could do something like this. A, then potentially from A, B or C, and then maybe they meet back up at a D and then continue the program. Or maybe, I gotta give myself some more room. Go over here for a second. Maybe we really like the A block and the B block. We'd like to keep going back and doing that all over again. So these are called branches. You see they kind of like branch out. That's the idea. And these are called loops because they, if you draw your programs with these arrows and things, eventually you're making a loop and coming back. All right, so in conditions we'll talk about branches, but loops I might give a little bit about right now because we'll need to use loops for motion. But we'll cover those in depth later. Don't you worry. All right. But before any of that, I want to talk about custom variables, because right now we've been using that answer variable, which may not do everything we want it to do. All right. So let me make this a third different program start when we press the space key. And you can change this to many things and have different things happen depending on which key, but let's pretend we press the space key and we want a third different kind of program to run. All right. So the idea is we can make variables to make our lives easier. Okay? They store information that we can then go and use later, and maybe I should say that in the PowerPoint. Yeah. So now we're going to say, x instead of 1,234. So variables are all about making your life easier, making your programs easier to read, things like that. So right now, when you start up Scratch, it makes a blank, a fresh variable for you called my variable. And is that a great name? You can right-click on it and go to rename variable and say something a bit better, like, I don't know, x. Why not? So here's x now. And we can do many things to x. You can see all of these 4 options that we can do right now. Well, okay, here's x. Right now it has no value, right? Now you should always make sure to give your things values. So at the very start, oops, this is a bad thing. I don't want it to be a rainbow. At the very start, when I made this x variable, it's anybody's guess what's there. In many programming languages, this is a problem right now, but it looks like Scratch is very nice to us, and it starts out every variable at 0. Every new variable for us at 0, and that's nice. This is like 0. And not a question mark, I guess. So right when it starts out at 0. And you can do things with that, but let's give x to be whatever value we want it to be. Okay? Okay. So set x to 42. That's what we want to happen. So if I click that, it'll do that. It'll run it for me, pretend. And then if I click x, it'll say 42. You can also show the variable in the program window with saying show variable and then click the variable that you want. So it'll show it up here if you can see that right next to this green flag and the red stop sign. Okay, it says x42. Cool. So you can do things like that. So let's do this. When space is pressed, set x to 44 now. And then we're going to show the variable x. Okay? So here I am in my program. if I click the sprite, it starts this program. We don't want that. Stop. If I press the space key, it immediately runs the program. It sets x to 44, shows it, it's up here. You see that? You can also say it, which might be easier to look at, but just pretend everything's up here for now. Okay, what good is this? Well, you can also hide the variable. Click, goes away. Stays there, I guess, until you hide it. Well, you can build up computation with these variables. You can say set x to 44, show it. Then you can start changing x. Okay, change x by 1 will increase the value. And then we can show it again, perhaps. You see that? So I'm going to press space, and now it shows x45 because it immediately. Now this is a timing issue, and this is why you always want to pause when you do things. So what happened here was immediately it set x to 44. So now it's 44. And then it showed it for a split second. It showed x 44. But then our program immediately changed x to 45 because these things happen very quickly. Our computers are fast. And then it showed the x again. And so really, as the user, we can't see that quickly. Our screen doesn't refresh that quickly. What it showed to us was only x45. All right, that's the idea. That is a horrible looking x, so let me just redraw all of that and showed x colon 45, something like that. So if you ever want to see 44, you better slow it down. So our computers are fast, you should wait. Make it wait. And don't mind me going off the screen there. That's the idea. If you want to see something, you should just make your program wait for a little bit. Okay, so how do we do that? There is a block for everything, don't you worry. Dun dun dun. Let's see here. I don't immediately remember where it is, so I'm just going to search for it. Darn, it won't find it for me. Oh, there it is. It's in orange. Sorry about that. So let's just put it here. Wait. Let's give it 2 seconds. Why not? Now, if I press the space key, say 44, then change it to 45. You see that? So it really was doing that thing. It was just so fast that we couldn't see it. And so that's useful. We can have variables that do cool things and change. Okay? Let's see here. Now, let me check the time. Okie dokie. How fast should I spin is the next question. Well, as fast as you want, sprite. So let's perhaps change our program to have this new one start when I press, I don't know, the up arrow. And so what we'll do is have this little guy spin. Let me show you how to do that. So in order to make something spin, you have to change the angle, okay? So you got to make him turn. We can make it like 5 degrees, for example. And if you keep clicking it, he starts spinning. And wouldn't it be nice if our program could just keep clicking this for us? Enter the repeat block. So forever, really. Repeat forever, please. If you want it to repeat a certain number of times, you can say repeat. Let's actually do that. That might be a bit easier. So repeat 10 times, turning by 5 degrees, when you press the up arrow. Whee! See that? It's working. And this is maybe a slow spin, but you could ask the user now, how fast do you want me to spin? And you know how to do this. Okay, where is our ask? There it is. So we can ask, how fast should I spin? And then we'll wait for the user to enter that. That's what the ask block does. And then 10 times it'll turn by how much we said to spin by. So if it was 5, it would go just as fast. But now it'll go as fast as we ask it to. And now we're making cool programs now. How fast should I spin? I don't know. How about 25? Ooh, that's fast. Press up arrow. How fast should I spin? About 10. That's a bit more calm. Okay, isn't that cool? And so we've made our own variables. We've used the repeat block now. And maybe we can do extra things. But we'll get to that later, I think. Okay. That was fun. So this involves using the repeat block. And maybe I'll just save this here for future reference. So repeat does something. You see how it has something like that. It repeats its contents. In this case, 10 times. Okay, that is the idea there. Okay, now, let me check the time again. Yeah. Conditions and questions. So, excuse me, let me get some water. We just figured out how to make our program loop. We got to make it branch too. All right? This will be useful. So do one thing or another depending on something. So equivalently, we want our programs to do one thing or another. Depending on input, for example. Okay, and that is the idea. And the best example that I could have come up with is absolute value without the apps block anymore. Okay, so let's talk about this. Dun dun dun, back to the browser. Now, if we scroll up to control, we got some more stuff. We used wait, we used repeat forever, kind of makes sense, and we'll talk about that more later. We now have if and if then, I guess, and then we have if then else. Now we need to talk about some things. Alright, so let's talk about Booleans, which is a fancy word. It's named after a man, George Boole, I think, was his name. His last name was definitely Boole, though. I might be getting the first name wrong. But you can go back to your first lecture and remember it correctly. Okay. So Booleans. What in the world are these things? Actually, let's use this kind of slide. So named after Mr. Boole, and Booleans are variables, or they're values that are true or false. Okay, and you can see where this is going to help us here. So this is very useful because we want to be able to say things like is answer less than 0, because in that case we know it's negative. And we want to do something if that question is true. You see that? So for example, absolute value now. And you can combine Booleans, and we'll talk about that, don't worry. For example, absolute value. So we got from the user the answer, which was whatever they typed in, and it's a number, right? So if it's negative 42, we want to do something different than if it was positive 42. Okay, I hope you see that. Now, let's kind of like section these off. All right. In this case, we want to take this answer and print out 42. In this case, we also want to print out 42, but how we got there is different. In order to get from here to here, you do nothing. In order from here to get from here to here, you could apply the abs block, of course. Or you could say negative 42 times negative 1. You see that? And so you could do something different in each case. Let's be rainbow, why not? That versus that is this idea of branching. So kind of what we want to do is get user input, stored in the answer variable. Then we want to check and see if that input is negative. And then finally, we then want to, depending on whether or not it was negative, so if that was true, a true thing, or if it was a false thing, false question ask, well, if it's false, we know what to do. If it's not negative, just do nothing, display the number. Yeah, that's a horrible looking Y. Display the number. Otherwise, and that's just one thing to do, otherwise, we need to change the number, multiply the number by negative 1. And then we can display it. Okay, you see that? In each case, we do something different. And that is, I think, what I want to do here. And then I'll have to pause for a second because I forgot to make a slide with your assignment. So, okay, let us now go and try and make this work. Okay, so we want an if-then-else block, and we can perhaps have our program work. What's our favorite event? Maybe when the down arrow is clicked, why not? Or pressed. So we're going to use if-then-else, and the idea of if-then-else is this. Oops. There we go. So let's talk about it. All right, hello. Sorry, my computer decided to crash, so I had to remake everything up until this point. So we were here. We're talking about if-then-else, and we were trying to understand what this block gives to us. So let's figure this out. Dun dun dun. Right here in your if block is where the condition goes. This is called the condition. And it's something that can be true or false. So it has to become true or false. I could write that better. And the idea is it has to become true or false. You don't just put the word true, the word false there. You can put something more complicated, like a test for if, like answer is less than 0, something like that. And we'll put that there in just a second. So this is the condition. It has to become either true or false. And then we have what's known as the body of the if statement. It's the if part. And this is what gets executed. You can put as many blocks as you want right up in here, and those will happen. Those will run when our condition is true. Let's call it cond. Okay. And then finally, this is called the else branch. So that was the body of the else. Weird terminology, I know. And so in the case that our condition was false, this will be run instead. Okay, now, and you can see, once all this stuff is done deciding what it needs to do, it'll either do option 1 or option 2, depending on our condition. You can put more things down here that just happen after the whole complicated process has been finished. So this is kind of where all of those things come back together. This would be like D in this example here. That one. Okay, so yeah, you can have more things after that. If then else statement. Okay, so now the idea is we need to make absolute value without the abs block using this if condition. So let's go back and let's figure this out. So, well, we need to ask again, let's see, first some kind of number. We need to get a number. So let's go and get one. And so then answer will be populated with whatever variable we get. And then we need to do something depending on whether that number was positive or negative. And we can test for those things here in the operators. We can either use greater than or less. I think I'll use less. And we can put the answer on the left. Is the answer less than 0? Because that'll test for negativity. Okay, so I'm going to press the down arrow. No, just got to stop this first. Press the down arrow. It'll ask us to enter a number. Here is 42. Hit enter. So now answer is populated with the value 42. And I can click this fancy block that performs an operation on answer. Is 42 less than 0? Click it. It says false. No, that's not currently true. So I'll press the down arrow again, enter negative 42. And now I'll click the block. It's true. Okay, so now you see how we can have our program operate differently depending on whether or not this Boolean result is true or false. Alright. So then, now you know where we're going with this. We can output. We can, let's see. We can say if it's less than 0, we'll say something. And if it's not true that it's less than 0, it's greater than or equal to 0, we'll say something else. Alright, so if it's less than 0, we'll execute this part of the if statement. And we can say, let's see here, we can say answer times -1. And the idea is that, oops, sorry, answer times -1. And what that will do is, can I write a little comment here? This will make, I don't know if you can read this, but when I give you the code, it'll be at least readable, I think. How about that? There we go. This will make answer positive now. And in this case, answer was already positive, so we can just keep him. Keep him how he was. Okay, I hope you see what's going on here. Boop, boop. Those little 2 comments for us. And so now we're ready. We are ready. Down arrow. Enter a number. 42. Enter. Positive 42. We hit the else branch. Okay, okay. Down arrow. Negative 42. Enter. 42. We hit the if branch. Okay? So that is beautiful. And I think that's all I wanted to say about this. And so I will be back. I'm going to add a little slide here with your next assignment. Alright, time for your next assignment. I realized it was just a lot easier to put this blank slide in and go straight to Canvas. Okay, so here's your program assignment. It will be about teleportation, and feel free to make this as creative as you want, but here's what I require. You're going to make the Scratch Cat or whatever sprite you want teleport when you click it. So when that sprite gets clicked, your program needs to do the following. It should make that sprite reappear magically after being hidden somewhere else on the screen, some random location, okay? And then after that sprite is moved, you'll have it say, I am above the middle if it teleported above the middle line, or I'm below the middle if it teleported below that line. And let me just show you what that means very quickly. So here is your program screen with your sprite. Okay, and in the middle is the y=0 line. You remember the coordinates that every sprite has. So if the sprite ended up with its y coordinate above the middle, you'd say, hey, I'm above the middle. Otherwise, you'd output, hey, I'm below it. Okay, that's the idea. And I'm going to show you an example in just a second. And then optionally, you can play a fun sound like pop or something after it teleports, and I'll show you how to do that. But yeah, those are the minimum requirements. I would really prefer it if you would upload a video of your program running, okay? You can record it with your phone. Zoom has a screen recording feature. I use this program called OBS if you're interested in that. But please try and get that working. If you can't get it working this time, just go ahead and upload a screenshot and make sure I can see your code definitely so I can make sure it's doing the right thing. And then come to office hours so that I can teach you how to record your screen for next assignment, because I think I will probably end up requiring recordings in the future. Okay, so just keep that in mind. And so here is the program running. I'm going to click my sprite. It's going to go somewhere and magically reappear and say where they ended up. So Scratch Cat ended up below the middle line, the secret middle line in the middle, at a negative y coordinate. So below the middle. Above the middle. Click, pop, above the middle, below the middle. And you can't hear this on your computer right now, but you can have it play sounds. There's this sound thing right here, and you can get fancy sounds that you can find from the little picker. You can search for a sound. I searched for the one called pop, and I added that. Okay, I only needed one, but now it's there. It's part of my program, and I can say meow or pop. But you can pick whatever one you want, and this is not required. Here are the blocks that you will probably need to use to make this work. Go to random position. Obviously, if then else is going to be necessary. Y position gets your current y coordinate. It's a variable. It's reset to whatever your current y coordinate is for the sprite this program belongs to. So right now, the y coordinate is 8. If I move the sprite, the y coordinate is now 171. Now it's negative 43. Okay? And then to get it to move, you can show and hide if you'd like, but go to random position also does that. But I'd like you to play around with show and hide. Maybe instead of go to random position, you could do glide to random position. And then, I don't know, hiding and showing might be more necessary at that point. But yeah, it's up to you. This is just to get you practicing this if then else. And yeah, enjoy. Hopefully you make it slightly more creative than my blank screen. But yeah, that's all I got for you. I'll see you next time.